So we're going to start factoring, and our basic rules of factoring are going to be to first find the GCF, the greatest common factor, always. That will make your life easier. Next, you'll look for grouping, and usually if you have 4 terms, for sure you'd want to try grouping. There is also a way for grouping in trinomials that you can try in section 6.4. Then you want to make sure you look for a difference of squares. We talked about those in chapter 5. Don't force them to happen if they're not there, but definitely they're pretty easy to spot. Then the last step would be factoring the trinomials, which can be one of the tougher problems, but hopefully we can work our way up. So now we have a polynomial that we want to factor, and it's got 2 terms. So my first step is to always look and see, do I have a greatest common factor going on? And both of these coefficients are even, so I know that 2 will go into both of them. I've got an x in the first term and an x squared in the second term. So they don't have an x squared in common, but they do have that 1x in common. And then there's a y squared in both terms. So the simplified polynomial will become the factored form of itself by factoring out a 2xy squared, which leaves me 2xy squared times what will give me the 2xy squared in the first term, and that'll be 1 plus 2 times 25 will give me the 50, and x times x will give me x squared, and the y squared's already in that first term there. So now I've got multiplication, remember, as my main operation, as opposed to over here my main operation was addition. And so that's, again, what is helping us distinguish between what we call simplified form. The first form of this is simplified. And after I look at this polynomial in here, the binomial in here, that can't be factored anymore. This is a monomial, so it can't be broken down anymore. And so the bottom, my result, is the factored form of the polynomial. Make sure you're aware of how to spot whether a polynomial is simplified or factored. It could be in neither form. It could be in an in-between stage. So be sure you know that a factored form, the main operation is multiplication, and all the polynomials are prime. This problem is similar to the previous problem, but because we now have a common expression rather than just one common variable, sometimes it freaks people out. But if you look here, notice I've got 2 terms. There's one term, and then subtracting the other term. So again, the main operation is subtraction. And this is an example of a polynomial that is neither simplified or factored, because we could perform the operation of multiplication here. So it's not simplified, but it's not factored because the main operation isn't multiplication. So, but I do notice that there's an x plus 5 in the first term, and there's also an x plus 5 in the second term. So I can do what I did before and factor out that x plus 5. Factor out that quantity. And that's going to leave me with, now remember, I took out the x plus 5 here, so it'll leave me with 3x in the first term. And I factored out the x plus 5 that was here, so that'll leave me with minus 2 in the second term. And then the next thing I check is that polynomial, can that be broken down anymore? No. Can this polynomial be broken down anymore? No. Is the main operation multiplication? Yes. So we are factored. Ooh, so our answer is x plus 5 times 3x minus 2. So now let's combine both our greatest common factor and grouping to get factor this polynomial. Looks like this is a simplified polynomial. Again, what makes it simplified? Are there any operations that can be performed? No, because the subtraction and addition and subtraction, these would have to be like terms, and they are not like terms. So this is simplified, but I want to factor it. So I'm going to get a little sneaky here, and I'm going to group it. And I'm going to group the first two terms, and then I'm going to group the second two terms together. Sometimes when you group, it works out great the first time. Other times you might have to reorder the terms. And in the first binomial I have here, I've got common a 2 and an x. So there's a 2 and an x there, 2 and an x here. So I'm going to take the greatest common factor of that binomial out, and I should end up with 2x minus y. And then similarly, for the other binomial, I've got a 3 in common. That leaves me with 2x minus y. And then voila! I get all excited again now because the 2x minus y, there's a factor of 2x minus y here. There's a factor of 2x minus y in the other term. So I can take out that factor of 2x minus y. And in the first term, if I just took out that 2x minus y and placed it here, I'll be left with 2x. So I'll have 2x. And then in the other term, I took out this factor of 2x minus y. I factored that, so I'll be left with plus 3. Then I check again. My main operation is multiplication. Do I have any common factors here? No. This is a prime polynomial as well. So I'm done. This is my answer. I am factored. Next group to factor, these are my favorite because as we saw earlier, they're really easy to identify. We saw these in chapter 5. I've got only two terms, x squared and minus 36. Two terms here. This is simplified. I can't do any more operations, and it's separated by a minus sign. And I notice that the first term is a square, and we also know that 36 is 6 squared. And the key is you've got two squares, x squared, 6 squared, and you're taking the difference. So this is why we call it a difference of squares. And as we saw in chapter 5, the difference of squares will factor into its conjugates, right? Its corresponding conjugates. The square root of x squared is x, so there's my x. The square root of 36 is 6, so there's my 6. And then I just take one of them is plus and the other sign in the middle is negative, and I am factored. Dun, dun, dun. Done. Like I said, dun, dun, dun. Okay. Now, be careful with this one because a lot of students, they see the squares, x squared, and they see the 25, and they know that 25 is 5 squared. And they think, oh yeah, I'll just break this down into, x plus 5 times x plus 5. But think about that. If you broke it down to x plus 5 times x plus 5, you're going to have an outside term of 5x, another term of 5x, and there's no 10x in this expression here. So don't do that. We're going to erase that because that's what we do. We erase. Oh, I can't. Hold on. I'm going to figure out how to get rid of that. I don't want to erase all of that. Okay, here's how we're going to erase. There. So this is actually a sum of two squares. And a sum of two squares is actually already factored. So this is already in factored form. One of the few polynomials whose simplified form is the same as its factored form. Isn't that interesting? So don't be fooled. No sum of squares. So here's another difference of squares, but don't be in too much of a hurry to do the difference of squares, because remember our first rule of factoring is to take out the greatest common factor, and in this case we have a 4. So 4x squared minus 16 is actually 4 times x squared minus 4. And then we take a closer look, and we do have the main operation of multiplication, but notice this binomial is not prime. It is another difference of squares, so we need to factor that in order to be in factored form. And so we still have the 4, and then we have x plus 2 and x minus 2, our two conjugates. And now we look, and those are prime factors, and so this is our factored form. Now I do want to go over what you would do. I think in the next slide I'm going to go over what you would do if you hadn't caught that greatest common factor. So what would have happened had you forgotten to take out the greatest common factor first and just identified the difference of squares? In that case, you would have come up with the conjugates 2x plus 4 times 2x minus 4. But then when you look further, you see that this binomial is not prime. There's a factor of 2 here and a factor of 2 in that 4. And the same thing with this one as well. So you would then have to remember to take out the greatest common factor. And so you'd have 2 times x plus 2. And then over here you'd have 2 times x minus 2. And then 2 times 2 will give me 4 times x plus 2, x minus 2, which is the same factored form that you got earlier in the previous attempt. And that's because the factored form of a polynomial is going to be unique. So no matter how you get there, you get to the same factored form. But I think it is easier to take the greatest common factor out first, as in the previous example. When factoring trinomials, there are a few methods that help people, and I think you have access to some videos for those as well. So I'm just going to remind you that when you factor a trinomial, it's usually going to factor into the product of two binomials. And so using trial and error, we know that the first factors have to multiply to be the x squared. So these first two factors, x times x, have to give you the first term of the trinomial. And then the last factors here and here have to multiply to be the last term of the trinomial as well. So the last terms of the binomials have to multiply to be the last terms of the trinomials. The first terms have to multiply to be the first term. So, and if I tried, for example, factors of 12, if I tried 2 and 6, for example, and let me get that, x plus 2 times x plus 6. So this is the trial and error method. And when I check the OI in the FOIL, the outside will give me 6x, and the inside will give me 2x. So guess what? This is actually not going to work, because when you add those two terms together, you get 8x. And the middle term is supposed to be 7x. So that didn't work. So you don't erase at home. I'm just erasing on the screen here. But you would just put a line through it. Actually, I should show you that. So you had x plus 2 and x minus 6, and you just showed that that didn't work. You want to put a line through it, though, so that you know that you tried it. I've seen students on exams just keep trying the same thing over and over again, and when they erase, they don't remember that they already tried it. So let's try another factor, some other factors of 12. And in this case, 3 and 4 multiply to be 12, and when you check the outer, you get x times 4, which would be 4x, and the inside 3 times x would be 3x, and 4x plus 3x gives me the 7x that I wanted. Again, check to make sure that you've got a main operation of multiplication and that these polynomials are prime and you're in factored form. So another good time to remember your first rule of factoring is to take out the GCF. So notice all of these terms have a 2, a factor of 2 in there. And so I'm going to factor out that 2. Make life a little easier for me. 2 times the quantity x squared plus 5x minus 6. And in this case, the trinomial is going to factor this trinomial. I'm not sure if it's prime or not, so I'm going to try some factors of 6. And after trying them, I think I'll discover that I think 6 and 1 will work, because when I have x plus 6 and x minus 1, that's going to give me the negative x plus 6x will give me that 5x in there. And so now I've got that this polynomial in simplified form is this in factored form. Be done. Last example here, as we saw on the Chapter 5 worksheet, this is one of those special perfect square trinomials. Notice you've got a perfect square in the front, x squared, and then the 16, remember that 16 is 4 squared, so you've got a perfect square in the back. And then notice that the 8 is 2 times the 4, so there's that relationship. This is another one of those perfect square trinomials. When you factor it, you're going to get x minus 4 times x minus 4, and you might also see that written as x minus 4 quantity squared. Either one of these answers will work, either this one or that as well. They're both in factored form.